Lyle and Ed want to come on up?
Well, good morning, ladies and gentlemen. Probably a lot of this is going to be a little bit repetitive from what Mr. Liberati showed, but I'm going to focus more on, I had all this stuff, but I think I'm just going to wing it now because I'm going to focus more on Georgia and the differences and the pitfalls and stuff that we run into. The first thing, one of the hardest things that we come across is finding actual rebar depths. So if the plan design is for 1.5 inches of overlay, you basically have to have 1.5 inches over the top of the rebar, or you're going to get continued delamination. So the interstate systems in Georgia were built in the 60s and 70s and widened throughout the years. And whenever they widen these, you have lap bars, and they're never, when they lap one widening to the existing deck, and it's never ever precise. So we always have problems with rebar heights. So what the state of Georgia kind of did was they allowed you to raise the bridge profile to get the design thickness. And then, of course, to get a smooth transition, you had to taper them back down to the approach slabs. So we do this in like a 24 to 25 foot transition on each end of the bridge. And this really, really helped our process because, as you know, in Atlanta, working at Friday night at midnight, Robbie or used to be Clayton are not available. You had problems. And it's hard. You don't know what you get into till you open the bridge deck up. So through time in this process, we cured that. We would just naturally raise the profiles of the bridge and tie them back down into the existing approach slabs. Now, luckily in Georgia, we don't have a lot of steel headers in the bridges. In other states, this is hard to do, and it takes more. You got to raise headers and stuff. But that's been one thing. Another thing is, in rare cases, seldom, you blow through the entire bridge deck. So, and you have to fix these things. And we have bird netting, which basically takes up our entire summer. The nesting season is from April 1st to August 31st. So we had problems fixing these blow-throughs or patches upon the bridge decks. So what the state of Georgia recently has done is they've hired biologists to come out. So you notify them 30 days before you're getting ready to start, and they will come out and monitor the bird activity. And then when the actual construction process goes, they will come out and monitor, so they will relocate nests and stuff, and this takes care of all the bird netting. There's no more bird netting in the state of Georgia, which has been a really, really good thing because bird netting doesn't work, as you all know. It kills birds, and then everybody gets upset, and we all do. And now I want to introduce Ed Haden. He's Vice President of IVS Hydro, and he's going to talk about the hydro demolition stuff, but as you can see, mine's shot. Thank you.
Okay. Good morning. So I'm going to, just like Lyle, run through the latex and the hydro process in the state of Georgia, kind of not one particular project, but just what we have experienced. I think they did their first latex overlay in 2016, and we've been there since the beginning, and we're still here now. And I'm just going to run through some specifications, how the process works, some things that we've done that has made it successful, I think. So typically in Georgia, we have acted as a subcontractor. And what our first step is typically to start working on our mix design. What I have up here is the Georgia mix design, what they specify or what they want in their mix. Just to point out a few things is they do require 750 pounds of type 3 cement or 825 pounds of type 1 cement. They do require a number 7 aggregate size, which is common in a thin deck overlay. Also common is they require 24.5 gallons per cubic yard as well. Now their requirements are they are pretty stringent and difficult to meet these. We've met them with success each time, but they do require compressive strength of 3,000 PSI in 24 hours. And I did want note that during their calibration or their field testing, they also do, they require the mix to be tested in the field, not in the lab, and they require 3,500 PSI within 24 hours. So kind of once we have our mix approved and we're using all Georgia DOT materials, we kind of move on to our volumetric calibrations. And during the volumetric calibrations, Georgia requires basically three things to be able to pour latex in Georgia. You have to be a certified concrete batch plant operator. Your equipment has to meet the spec of the C680, ASTM C685. As a supplier, you have to be on the QPL or approved by the engineer. And furthermore, once your mixer is calibrated, they do require your mixer to be recalibrated every 6 months, or if there's a problem with your mix. We saw a picture of a yield box that Blake had shown, and say you under yield on something, hey, let's recalibrate. So, so far we haven't had any of those issues, but some common sense stuff that I think that we've been able to do in Georgia that has helped in the process is, just keeping things consistent. What you do on your calibration day is what you need to do on your pour day. And keeping, it's just common basic housekeeping activities such as covering your aggregates. Covering your aggregates is something that is sometimes overlooked, very important. It keeps your moistures regulated in your coarse and your fine aggregates, which is very important. We check that we check our moistures on calibration day and on pour day and make sure they're, similar. The other thing that I can say is having competent personnel out on the bridge deck, out on site. Typically in Georgia, the way things operate is we have a third-party consultant, a person from materials, and then an IVS operator out there as well. And I can honestly say it's been great working with the Georgia DOT. They have very competent personnel, and all three of those individuals really interact and work well out on the bridge deck. And it's not so much of a sense where one's asking the other questions. Everybody knows their stuff, which is really good and is important to have, because sometimes stuff does happen out on the deck in the middle of a pour, things don't go right or something. Each of those people can act as a checks and balance for each other, which I think has been, aided in the success of these projects. Kind of moving on, once we get our mix approved and we're calibrated, we get out on the deck, typically on weekend closure, and we start our hydro demolition operations. All the LMC operation in Georgia has all been shallow cut, and so typically with our hydro operations, we do test, we calibrate our machine for each bridge deck, for each required plan specification. We calibrate our machine on a sound piece of concrete and an unsound piece of concrete. And, you calibrate on an unsound piece of concrete, you do check to make sure that you're getting out all the bad delaminated concrete. And on the good and sound concrete, you're checking to make sure that you achieve the planned depth and the overlay depth. I could probably talk for a long time about the benefits of hydro demolition. I'm a hydro guy, but I think that Georgia has seen, and I think the biggest advantage really in a shallow cut and an LMC operation is that it really gives the state the best overall bang for the buck, because it is a pretty invasive repair method, and it's a total surface repair method. No areas are missed. And you're going through the process, usually pretty large areas, as Hydrotech and Blake had pointed out. They were doing 10,000 square yards and 4 weekends. So you're able to accomplish a lot in short durations. And that we've seen through empirical data that it does extend the bridge deck by 25 to 30 years. Okay, so kind of tacking on just a little bit to our hydro operations. Most people have a little bit of questions, when looking at different systems or different things that can be applied to a bridge deck to rehabilitate it. And one of the concerns is water. And I'm a hydro guy, and you're always kind of like, gosh, do you want to put water into the equation? And I think that one of the ways that we have been able to mitigate some of these issues is by performing what I call a closed loop system. And we basically do this during production and cleanup. If you can see on our picture right here, there is our robot attached to our vac truck via vac hose. And this vac hose basically sucks up all the water as you're cutting out on the bridge deck. And in doing this, it eliminates water running around the bridge deck. And it keeps the area dry, safe, clean. You don't really see water. Overspray is eliminated, which is great for the traveling public. And then our cleanup operations, the picture right above that, again, same process. You go through, you spray some water to get the remaining debris off the deck, and you suck it all up in the same operation. The effects of kind of implementing this system is overall, it makes your work area safer. We've done a lot of closures on I-75, I-85 in Atlanta. You're taking on a Friday night, going from 5 lanes down to 2 lanes, and it's pretty chaotic. All of us who've seen it and happen. So really doing small things or doing big things to make your work area safer, declutter your work area. In doing this method, we catch all of our water in a vac truck. So it eliminates having an extra frac tank or other big bulky tanks out on the deck, which is, like I said, is really kind of paramount when you're in a, high stressful situation at, the first start of a shift on a weekend closure. The second thing about controlling the water in this manner is it reduces human error. This is all performed mechanical. It makes the process simple, and it takes any human error that can come up. Most notably today, it's cell phones, or someone's on a cell phone not paying attention to something, and water overruns your containment area, and you got water out in the middle of traffic and everything else, and it can just be a mess. Overall, I think in doing this, it has allowed, to give the state of Georgia a less environmental footprint overall. I think it puts the focus back on getting latex modified concrete placed in the weekend, less on the hydro operation. Okay, so overall, I think just general advantages of doing the LMC in Georgia. Again, I think we've all touched on, you can get a lot done in a short amount of time. And what we've seen too, I kind of wanted to point this up, or bring this up as well, is that, in all the projects that we've done in Georgia with LMC, there's been, to our knowledge, a lack of shrinkage cracking, no delaminated concrete that's popped back up. And, I think that relates to a few factors. One is the placing and finishing operation. That has to be, paramount and good. The being able to batch some good concrete as well. And, I think another piece of it is it really relates to the latex itself. Latex in its simplest form is a water reducer, which, as we know, all aids in reducing shrinkage cracking. And then finally, the word super glue is up there. And this, I can't coin this term myself. This came from Lyle. The first time we were out on a project, and he felt the latex before we started, which it's very, very tacky. And then when he felt the concrete with the latex, and he's like, man, this stuff feels like the concrete's been injected with super glue. You know, and I think it talks about the bondability and the tackiness of the product itself. And when placing a thin deck overlay, you definitely want the stuff to stick. So, you know, I mean, I think that we've had those successes in Georgia, and I think we'll continue to have those successes in Georgia. Do you want to go through any more? Okay.
Thank you.
All right.
Any quick questions? You know, they didn't share any of their specific projects, but they have them, and they're more than willing. If you got a question like something you might have seen on Blake's, it's saying, well, how'd you handle with that in Georgia? So feel free.
Yeah, the question I have, Lyle, you had mentioned some concerns about the decks, the pop out of the decks, the blowouts. I know Georgia, a lot of the older bridges have thinner decks. Any recommendations on how to prevent some of the blowouts? And what type of bridges have you seen most of the blowouts occurring in?
Luckily, with the shallow cuts, we've had very, very few, but one way to kind of get out ahead of it is sounding the deck before you ever start anything. And then you can isolate used areas, and they can be pre-passed before you mill or hydro. It's a more of expense, but like if you walk out to a bridge deck and there's a lot of patching, the shallow cut, you're probably not going to have issues, but you might. You just got to be prepared for it. And it's basically just when the hydroblast machine blows through, you square it up with jackhammers and put plywood up and pour it full depth with the LMC.
I have a quick question. What is your shallow cut? Will you explain your shallow cut?
A shallow cut is basically designed to go above the rebar. A deep cut goes an inch below the top mat. And that's the difference. And back in the 90s and 2000s, Georgia did a lot of deep cuts, but it's slower, and the environmental footprint is a mess. A mess, because you can't control 200 gallons of water a minute. It's hard to control. Thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.